10 volts. I need to find the secondary current. Well, we can use Ohm's law for that. Can we take voltage of the secondary divided by the impedance of the secondary, which is actually this? Yeah, so what's 10 divided by 2K? 5 milliamps. So that is the secondary current there. So now, we can't determine what the primary current is unless we have a load, right? Because that's why a transformer is a self-regulating device. It compensates for changes in the load. So to find the primary current, there's the formula. Secondary current times, hey, number of turns from primary to secondary. And since we know it's a step-down transformer, the current ratio is what? 1 to 2, isn't it? So should this primary current basically be half of this, right? Yeah. The primary current is 2.5 milliamps. And, well, RMS technically. Because if we got, yeah, 2 over 1, yeah, that would be the other way around. Yes. Good catch on that, Mr. Head. You got 2 now.
Thank you.
All right, so what we got? What we got? Yeah, secondary. Yeah, yeah. Sometimes you gotta watch. So let's see if that makes more sense. So 5 milliamps times 1 over 2, or half of that. There you go. That makes sense. Primary impedance. 2 ways to find it. Can we use Ohm's law? Sure. We can take 20 volts divided by our primary current, gives us what? Primary impedance of what? Should be like 8. Yep, 8 ohms. So I've got 8K, 2K. Can I use this formula? Primary impedance equals secondary impedance times turns ratio squared and get the same answer? Yes, you can. Secondary impedance is this. Where is it? 2K ohms times, this should be right this time, primary over secondary. So it's basically 2 squared, right? 4 times 2K, there it is, 8K. Make sense? Okay, here's the magic. Ready for some magic? Oh, you didn't look away. All right, good job. Can't get quartered. We need to do something to this load to prove something, right? Yeah, we gotta change it so we can prove that this is true. The transformer being a self-regulating device. So this time, since in the lesson we increased, let's decrease. Woo! Let's make that thing like 500 ohms just because we can. So first off, before we even solve anything, if I decrease the load, the secondary current's going to do what? Increase. Since the transformer is a self-regulating device, if the secondary current increases, the primary current's going to do what? That's why we're going to prove it. Because some of you don't sound too sure. That's the answer. It's going to increase. We need to prove that. Is the secondary voltage still the same? Because just because we change the load, there's nothing in this formula that has to do with the load. But the secondary current's going to be different now, and it better increase because we decreased the opposition. So now it's 10 divided by 500, which gives us a new secondary current of, oh, hey, did it increase? Sure did. 20 milliamps. How do we find the primary current? Well, here it is now, the right way. Secondary current, 20 milli times what? Basically half of it, right? So half of 20, what? 10 milliamps. Let's be technical. Primary impedance, what is it? Ohm's law or this? It is what? 2K ohms, okay. So a transformer is a self-regulating device. Why? Because it compensates for a change of load. That's exactly what it does. It's the ratios. You can't argue the ratios. They are what they are what they are. Capacitance and series, what did we discuss? We have to reciprocate this time. Because I explained to you in a series configuration, the power supply sees a bunch of distance between capacitors in a string. And I'm not going to go into that again because that, for the exam, is irrelevant. It was just to explain to you why we reciprocate in series and do what in parallel. Total capacitance add. Because in parallel, the power supply sees the capacitors in parallel as one with giant plates. That's where the term capacitance comes from. Capacity, how much charge can it hold? That's the deal. We always treat ohms like ohms, don't we? Sure. In series, we still add ohms. And in parallel, we still reciprocate ohms. Rules. Don't get out on capacitors with the rules because it's different from inductors and resistors, isn't it? Sure. Finding total, that is. Not the ohms, but the capacitance versus inductance or resistance. It's different. How do we describe capacitor? Physical component that does what? Sure. Yes. Because the magic word now is what? Voltage. Voltage. Oh, we see that line green back there? Can you see it?
Yes, sir.
Aslan, can you see it? Okay. Capacitance has to do with capacity or the ability to do what? Ability to store what? What are we storing? Groceries for the winter, what? Yeah, store. Look, you can see this in different flavors. Ability to store electric. I can put in parentheses electrostatic. Same thing. Electrostatic charge. And it's still energy. It's just in a different format, isn't it? So now we have two conductive plates, and in between the two conductive plates, what do we call it? A dielectric material. It's something that is non-conductive. Because I can take a balloon, rub it on my head, and that balloon is made of, well, not rubber, but whatever the hell they make that out of poly, whatever the hell.
Polyester.
Okay, whatever. So it's basically non-conductive material. But can I store a charge on that? Because I'm friction rubbing on my chair, but still, there's going to be some charge there stored. And then I can take that balloon and I stick to the wall or whatever. Right! Paying attention? Capacitive reactance, what do we call that? AKA? Right? Yes. It's ohms, isn't it? Is it in opposition to something? To what? Oh, it's opposition to voltage. Well, the capacitor itself, but yeah, it opposes a change in the voltage this time. And so it's basically this based on frequency, right? So it opposes that change or variation in voltage. It's just like X sub L. It has to do with frequency. I didn't write the formula this time, but what the hell is it? What is the formula for X sub C? What is it there, Aslan? X sub C equals what? But you don't have that one memorized? That one you guys should know. No, Aslan's going to tell me. What is it?
1 over 2 pi FC.
All right, good job. Good. So basic characteristics.